beautiful day in this neighborhood, a beautiful day for a neighbor. Would you be mine? Could you be mine? It's a neighborly day in this beauty wood, a neighborly day for a beauty.
Oh, hi.
Would you be mine?
I didn't see you there.
Could you be mine? I have always
Oh,
wanted to have
what a nice
neighbor
afternoon
just
here in
like
Ardmore, Pennsylvania.
I've always wanted to live in a neighborhood.
Great day for some logarithms. So, if we were asked to graph the function f of x equals log base 2 of x, this is something we've done before. That's really what I used to consider to be the parent logarithmic function. Okay? Just to kind of refresh your memory of what logarithms are, they're the inverse of exponential functions. Okay? So probably the easiest way to graph this is just to consider its inverse, y equals 2 to the power x, and then flip-flop x and y. Okay? So if we do consider y equals 2 to the power x, and make an xy table for that function, we want to choose some negatives and 0 and a couple of positives. All right, let's choose 3 also. So if we plug in negative 2 here, 2 to the negative 2 is 1/4. 2 to the negative first is 1/2. 2 to the 0, of course, is 1. 2 to the first is 2. 2 squared is 4. And 2 to the third is 8. And just to remind you about all the exponential functions we've just handled, one property of exponential functions is that as x increases, as you're adding a constant value to x, the value of y is being multiplied by a constant value, in this case, the number 2. Okay? So the inverse of this is going to be the logarithmic function. So for this function, y equals log base 2 of x, we have just the reverse, right? We have 1/4 negative 2. We have 1/2 negative 1. We have 1, 0. We have 2, 1, 4, 2, 8, 3, and so on and so forth. Okay? So just let's kind of pick this apart a little bit more than we did in the last unit with parent functions. Okay? This function, what happens is, whereas in the exponential function, the x value is the exponent and the y value is the answer, now it's reversed. Now the x value is the answer and the y value is the exponent. Okay? So the exponent, the y value is really the exponent here. So when you're evaluating a logarithm, log base 2 of 8, for instance, well, that's equal to 3. Log base 2 of 4, that's equal to 2, and so on and so forth. So now the y value, the output, is what was originally your exponent. Okay, it's really all logarithm is it is an exponent. That y, this is the exponent. All right, the x is what was originally the output, right? Okay, so let's kind of use this concept to evaluate function value like f of 8. Okay, we already kind of know what the answer is going to be, but if the function is log base 2 of x, then to evaluate f of 8, we would just plug in 8 in for x, and we get log base 2 of 8. And again, what that means, what you're now looking for essentially, what this expression means is what power of 2 equals 8. This is what was originally your answer with exponents, is now 8. You're looking for the exponent. This to what power equals 8. Okay, it's going backwards from exponents. Right, log base 2 of 8, we already know log base 2 of 8, when x is 8, y is 3. The answer is 3, but you should be able to do this without this kind of a table. Okay, and here's how. When you're evaluating an exponential expression, oh, by the way, f of 8 equals log base 2 of 8, so f of 8 equals 3, right? In general, though, when you're evaluating a logarithmic expression, yes, you are looking for an exponent, right? But the safest bet is to write the logarithmic expression in exponential form. Okay, that's going to be the safest way out, because often, if you do that, you'll say, oh, I can write both sides with a common base, set the exponents equal, and solve. This problem here, evaluate log base 3 of 1/9. You don't need to consider the whole function, log base 3 of x, and think about inverses. That takes too long. What this means is, again, when you're evaluating a logarithm, you're finding the exponent. 3 to what power equals 1/9. Write yourself an equation. 3 to what power equals 1/9. So you're creating a variable in there, which is okay. There was no x in the problem, but you're creating one to help you evaluate. Okay? So 3 to what power equals 1/9? Well, you can probably do it in your head. The answer is -2, right? In general, though, you can always write both sides with the same base. 3 to this equals 3 to that. And now set the exponents equal. So we get an answer of -2. So log base 3 of 1/9 equals -2. Okay? That's the answer. You don't really include an x in your answer because the x that we created wasn't originally there. Okay? Let's go into some different kinds of problems now. Okay, so we have up here, you're also just evaluating a logarithm here. Okay, but this logarithm has a base of e, right? The natural logarithm, that is the same as log base e of root e over e to the 4th. Okay, these mean the same thing. Feel free, if you're more comfortable seeing the base actually written there, you're welcome to change natural log into log base e. They mean the same thing, okay? So this is asking us, e, right, this little guy, to what power is this? Right? That is generally how you always want to consider rewriting from logarithmic form to exponential form. You generally want to, let me make a little box here and show you, all right? Time out with this problem, I'm sorry. But I did have a little note I wanted to go over just beforehand, just to double check that you knew this. This is the general rule of logarithms. If log base b of x equals y, then b to the y-th power equals x. So just to make sure you guys know this, you kind of have to memorize this, okay? But from this form, if log base b of x equals y, there's 3 letters here, right? The b, the x, and the y. When you're going from log to exponential form, you have to be careful which one you put where. It's the little guy, that's the base in your exponential equation. That's the exponent. Remember, what it equals is the exponent with logarithms. So b to the y equals x. Right? Just like log base 2 of 8 equals 3. Log base 2 of 8 equals 3 because 2 to the 3rd equals 8. Right? So you got to make sure you write this in the right order. Now, back to the problem. We have log base e of this argument. This whole expression is called the argument. Okay? So in other words, for putting this in exponential form, this means e to what power, we'll call it x, equals root e over e to the 4th. Now, recall from the last unit and from before that when we have an exponential equation, we want to write both sides with the exact same base. So the problem here is just write the right-hand side as a single base of e. So this is e to the x. Make this e to some power, and then set the exponents to be equal. So we have e to the x equals, well, e to the 1/2, right? The square root is like the 1/2 power. We don't want radicals with these problems. We want to write them as exponents. So we have e to the, I'll write the rest of it over here, e to the x equals e to the 1/2 over e to the 4th. And now because we're dividing like bases, we would subtract the exponents. So we get e to the x equals e to the 1/2 minus 4, 1/2 minus 8 over 2. Right? 1 over 2 minus 8 over 2 is negative 7 over 2. Negative 3.5, or negative 7/2. And now we're pretty much finished. E to the x equals e to the negative 7 over 2. So the answer is negative 7/2, or negative 3.5. Okay? Because it was just an x up there. So again, e to what power equals this? Negative 3.5. And again, that makes sense because we have a 1/2 power of e divided by a 4th power of e, and 1/2 minus 4 is negative 3.5. Okay? So that's all. Any problem where you're evaluating a natural log, they're actually not very complicated because one side of the equation will always be just plain old e to the x. right? Because you're looking e to what power is this mess. So all you have to figure out and kind of manipulate is, well, what power of e is this whole quotient in this case? It's negative 3.5. Now here's a problem you're going to need a calculator for. Okay, we're solving an exponential equation, but clearly we can't write both sides with the same base. All right? So e to the t over 3 plus 7 power equals 50. 50 cannot be written with the power of e. No way. Right? So the only thing we can really do here is use logarithms. All right? We're going to essentially, you don't need to show these middle steps. I'll show you, okay? But you don't need to show them. We're going to take the natural logarithm of both sides. So we're going to write the natural logarithm of e to the t thirds plus 7 power equals the natural logarithm of 50. Okay? Now recall that one rule of logarithms in general is that if your argument has an exponent, you can bring that exponent in front. Okay? That exponent of the argument can become the coefficient of the whole expression. So let's do that. T over 3 plus 7, whoops, not plus t, plus 7, times the natural log of e equals the natural log of 50. Now think about it for a second. The natural log of e, that means what power of e, because the base is e e. E to what power is e? 1. The natural log of e is just 1. So here we just have t over 3 plus 7 times 1. I mean, I'll write it here for a second, but it's not going to make a difference, equals the natural log of 50. Okay? So first of all, to make this easier, let me just save some time and just erase this times 1 is going to be itself. Right? We've got to figure out what this is as a decimal. The natural log of 50 is not pretty. We have no choice but to break out the old TI 83. And we do the natural log of 50, and we get 3.912 to the nearest thousandth, right? 3.912. Kind of makes sense because e is about 2.7, which is a little bit less than 3. So, 3 to the 4th would be 81. 3 to the 3rd would be 27. So it makes sense that the number is between 3 and 4. If we let e be about 3, then e to what power is 50? Well, okay, 3 point something. So we have t over 3 plus 7 equals this. And now it's a pretty basic problem. Right? We're going to want to multiply by 3 to undo that division in a second. But let's just take away the 7 first. So we get t over 3 equals negative, oh boy, 3.912 minus 7. Let me just do that carefully, actually. This is kind of embarrassing. I know I can't do this one in my head, but I want to save time. We get negative 3.088. I shouldn't say that. Some things take longer than others. There's no problem if you can't do that in your head. And now we would just multiply by 3. So we get t equals, well, this one isn't so bad, negative 9.0, maybe it is. 0.270 would have been if it was 0.09, so 0.264, I believe. If I had to guess at that. Let me just double check that. So 3.088. I know it's negative. I'll worry about that later. 9.264, yeah. Okay? This is the answer. Look, it's not as ugly as it appears. Once again, all you really had to do, you don't need to show too much work, but what really happens is you take the natural logarithm of both sides of the equation, okay? And then really the natural log of e becomes 1. So all you had to do was take the natural logarithm of 50 and then, round it. Take away 7 and then multiply by 3 to get the t by itself. It's not so bad, all right? So that's all for this lesson. Hope you guys are having a nice day.